last class, rather, I think we were looking at, we've looked at arithmetic mean, and then we've looked at geometric mean. So today we will start with the harmonic mean, which is the third main type of mean calculation. And then we will then go to like the second part of this module, right? Now, just as a refresher, can we, who can state the formula for calculating holding period return? Just state it out without consulting your notes. Holding period return. No one can remember the formula for holding period return.
I think that's the period 1 minus.
Yes, Bolaji.
Period. I think that's like the period 1 minus period 0 over period. I can't remember. I can't remember. I know it's the period thing, but I'm not sure I can remember.
Okay.
So price. Yeah, price. Like P1 minus P0, sure.
Okay.
Yeah, it's price.
Okay. So you're free to consult your notes now. I'm highlighting it because these are formulas you will need to remember. If you're asked a question, you will need to, the question might be simple, but you will need to remember the formula to solve it.
Yeah,
And
it's
so,
price.
yeah, so please, you can look back, you can go back to your notes and just look at the formula again and just bear it in mind. The question for this session might actually come in form of those simple questions that you can easily plug into the formula and get your answer. They won't put any kind of twist to it. When we get to questions or areas where they can add twist to the question, I'll show you. But for this session, the questions are typically straightforward. All you need to be able to remember is the formula, and you apply it, and you would get your answer. Okay. Second question as a refresher. Which one, geometric mean or arithmetic mean, which one would typically be higher? Arithmetic mean or geometric mean? Which one would typically be higher? Anyone?
Arithmetic mean.
Arithmetic mean. Yeah, that's correct. Now, when do you expect arithmetic mean and geometric mean to be close or the same? To be close or the same? What condition will make both arithmetic mean and geometric mean close or the same? Anyone? Guys, I hope you go back and study your notes after class, because we highlighted it, and I think if you check very well, you must have written it down as well. These are low-hanging fruit questions that you may be asked that does not really require calculation. Even though they might ask it from a calculation point of view, they might give you numbers, but if you look at it, you don't need to calculate anything. You should be able to just go straight to your answer. So anyone, what condition will make arithmetic and geometric mean close or similar? Does anyone want to try? Okay. So typically, the variability of the data set you have would determine how far, or the difference between arithmetic mean and geometric mean. So if you have very variable data, for example, if you have data that ranges from say -40 to +89, that tells you that your arithmetic mean will be significantly higher than when that range is than when that range is smaller. A smaller range will be when your range of return, for example, is between. I was talking about conditions that will make, or the condition that will make arithmetic mean and geometric mean similar or close. And I was talking about the variability of the returns. And I talked about having a return that is from -40, -40 to +80 or 89, for example. That's a wider range compared to a return range of, say, -4 to +12. Now, that's a shorter range. Now, for the wider range, you find that the arithmetic mean will be significantly higher than the geometric mean. In the lower range, it will still be higher. In the geometric mean, it will still be higher, but it's not going to be as significant as you have in the -40 to +89. And so that's the condition. Plus, if you have a data set that is the same, say maybe the yearly return is 25, 25, 25, 25, 25, for example, 25% every year, you will not notice any difference between the arithmetic mean and the geometric mean, which means the arithmetic mean and the geometric mean would be the same. So variability of the return determines the difference between arithmetic mean and geometric mean, and then the range of that return also would determine how wide or how significantly higher than the geometric mean the arithmetic mean would be. So today we'll start by looking at the harmonic mean, which is the third of the major mean calculation that we need to deal with in this model. Essentially, the harmonic mean deals with data that's been set up as a ratio. So sometimes you have data that they are a result of a ratio, or they are ratio in themselves. Now, the implication of this is if it's already a ratio, it means there is an implicit measurement sort of to it. And this is important because so the data you have might not necessarily be on a weighted average basis, might not necessarily be measuring the same thing. And therefore, when you calculate your arithmetic mean or your geometric mean, it may not necessarily put that into consideration. In fact, those other means assumes that you're dealing with the same thing. That is, you're dealing with the same what's it called? You're dealing with the same measurement value. Now I'll give you an example. If I told you that last year I earned 50% and this year I also earned 50%, right? Now you won't really ask me how much I invested last year versus how much I invested this year, right? So all you know is that I earned 50,000. The implicit assumption there is that I invested the same amount. So I could have invested 1,000 naira and earned 50,000 and earned 50%. And in the second period, I invested 100 naira and earned 50%, right? So really, what you're saying is whatever amount I have invested really doesn't matter, right? But if I, as an investor, if I aggregate that, that is, I add my 1,000 to my 100, and then I find out how much I've made. right, on the aggregate, you will find out that the result is simply not 50%. Because if I made 50% year one, 50% in year two, I'm saying that if you calculate my return at any particular point in time, I've made 50% return. It does not necessarily follow that way. So, but that is the problem that the harmonic mean really resolves, to say, if you then have data that already been expressed in as a ratio, or you have data that already been expressed as a percentage of other numbers, then you can then assign an equal weighting to it. Now, by assigning an equal weighting to it, then the outcome will be much more reflective of the actual performance that the investment or what you're trying to calculate is. And that's what the harmonic mean does. Now, to understand the harmonic mean, how is it set up? How is the harmonic mean set up? Because from a question and exam question point of view, the question for harmonic mean will be simple. What you need to find out is, when you see your question, what is the best approach? Is it arithmetic, geometric, or harmonic? If you're not asked explicitly to use harmonic, so you will need to decide, which should I use? How do you decide that? What the data set you've been given, is it like a percentage, or is it like a ratio, a fixed ratio? If it is, then the harmonic mean is the right thing to use. The other pointer for harmonic mean is that the best use case scenario for harmonic mean is what we call the dollar cost averaging, or the cost averaging. Now, and we'll see an example of that. So when you see a question where the question already talked about cost averaging or averaging, then implicitly you know they're asking you to do a harmonic mean calculation. So those are the two things you look out for. If the data is a percentage, or sorry, it's a ratio, or if the question used the word averaging in the question setup, then you know you are most likely being asked to calculate the harmonic mean. Now, what's the formula for the harmonic mean? That is given in equation 4, which is this. And so it's 1 over the data you've been given, 1 over x. You aggregate that, right? And then that will become, the aggregate becomes the denominator for the number of observation. And so equation 4 is your formula for your harmonic mean. The harmonic mean solve the problem of outlier. So sometimes you have data that has significant outlier, right? If you do have significant outlier in your data, the harmonic mean resolve that, because it attaches equal weighting to all of your observation, which does not really happen in your arithmetic mean or per se in your geometric mean, right? So take, for example, which has an example would have been given here. You have 6 data or 7 data, 1, 2, 3, 4, 5, 6, and then 1,000. And then you're asked to calculate the mean of this. The arithmetic mean of this is 145. But I mean, imagine 145 when you have 1, 2, 3, 4, 5, 6. 6 is the highest number. It's not even up to 10. And then just because you have one number out of the 7, one that is 1,000, your arithmetic mean is 145. So clearly your result has been skewed because of the outlier. The outlier is the 1,000, right? Now, but this problem is resolved with the harmonic mean. So if you did an harmonic mean calculation, you will get 2.86, which is much more reasonable considering the type of the data you have, 1, 2, 3, 4, 5, 6. So if you tell me that the average of 1, 2, 3, 4, 5, 6 is about 2.8, then it's much more reasonable than saying that the average of 1, 2, 3, 4, 5, 6, and then 1,000 is 145. I mean, clearly that average is way more than 90% of your observation. And so that's the problem that the harmonic means resolves. So, and you may get a question that says, when is the best time to apply the harmonic mean? Or what's the best use case scenario? Now, I've talked about two already. One is when your data is expressed as a ratio. Second is when you're trying to get an average, or when averaging, you're trying to get what we call the cost averaging or the averaging method. The third is when there is significant outlier in your observation. So when you look at your observation and you can see an outlier, then the best mean to use will be your harmonic mean. That will give you something that is much closer to more correct than the other types of mean. So those three scenarios you should look out for in answering your question on the type of mean to use. Now let's look at how the harmonic mean is calculated. So I mentioned earlier, when you look at investment strategy that is known as cost averaging, and we will see that in the question, in the next question. So let's look at question 6. Now, suppose that as an investor, you invest €1,000 each month in a particular stock for 2 months. So you invested €1,000 month 1, €1,000 month 2. The share price are €10 in month 1 and then €15 at month 2, right? So, which means in the first month, you will purchase 100 units of that share, because each unit is €10. But for the second month, you will only purchase 66.67 number of units, right, in the second month, which is less than the 100 unit, because the price is now higher, almost 50% higher, right? Now, so in total, the investor would have purchased a total of 166.67 units and having spent 2,000 naira, to get that. Now, so the average price paid per share will be 12 naira. So which means when you add the total amount you've spent over the total share you have, the average cost of each unit will be 12 naira. Now, this is important when you're doing your investment. You want to know what your average cost is, especially if you've purchased at different times. This happens a lot in the stock market, where you go to the market, you buy, say, 10 units of Dangote shares at a price. Next week, you buy another unit at a different price. But in your books and for your valuation, you want to know what the average cost is for you to be able to determine at what point should I sell, at what point should I, how much profit have I really made overall on this particular investment decision. So that's where this comes in. Now, if you do the harmonic mean, right, you will get €12, which is the same as when you use the actual cash you've invested and the number of units. But if you had just done a straightforward arithmetic mean, you will get 12.5, which is higher than the actual average that you should have. So this question, excuse me, this question simply buttresses the fact that when you are dealing with cost averaging, the best type of mean to calculation to use is your harmonic mean. Now, there is a relationship between the harmonic mean, geometric mean, and the arithmetic mean. And this is important for you to bear in mind. Arithmetic mean multiplied by harmonic mean equals geometric mean squared. Now, this is the relationship between the three mean measures, right? Arithmetic mean times harmonic mean equals geometric mean squared. Geometric mean squared. So when you remember this relationship, you might have a question in which you're given two of the means and you're asked to get the third one. You may not be given data, which means you get a question that says that the arithmetic mean is this, and then the harmonic mean is this, and then you're asked to get the geometric mean. Typically, if you have the data, you will solve for the geometric mean, but here you're not given the data. You're simply given the value of the harmonic and the geometric mean. But you can use those two data to derive your geometric mean. And in this type of question, most likely you will be given a geometric mean and one of harmonic mean or arithmetic mean, which means you would then need to solve for. So for example, if you're given a geometric mean right? Let's say you're given a geometric mean of 25, right? You already know that that is a percent, okay? Which means 5 times 5 gives 25, right? So it tells you that the geometric mean automatically is 5, not necessarily the 25, because this is geometric mean squared. So when you see when you're given a number, right, in this kind of calculation, and you need to break it down, beware of the square on top of geometric mean. So you know that the actual geometric mean, for example, is 5, not necessarily 25. And then when you need to plug in into this formula, ensure that you write out the formula this way, then solve for. You might be asked to then solve for harmonic or arithmetic, which means you solve backwards for it. And so just to state that relationship, it might be worth noting it down and remembering it. And then unless all the observation in the data sets are the same, right? Your harmonic mean is always less than your geometric mean. And your geometric mean, as we have learned in the last class, is always lesser or lower than your arithmetic mean. So your arithmetic mean is the highest, followed by your geometric mean, and then followed by your harmonic mean. Now, the only condition, like we mentioned at the beginning of the class, where you have harmonic mean, where you have your geometric mean equal your arithmetic mean, is if all the data in the data set are the same. And if you have that same scenario, it means it will also be equal to your harmonic mean. So it means that if you have if the data set, if your data set for your observation are all the same, then your harmonic mean would be equal to your arithmetic mean and would be equal to your geometric mean. And that's the only condition in which those three will be equal. But as long as they are not equal, as long as their variability or the range differs, like I mentioned earlier, then your harmonic mean will always be the lowest, followed by your geometric mean, and followed by your arithmetic mean. Now, the last bit in which this might come out is you might be given a question in which you're given an arithmetic mean. You may not be given anything else. You may just be given options and you are asked, what is the geometric mean? So typically, when you have your data, you know you can calculate the rest. But what if you're not given data to work with? You can simply look at the relationship. By looking at the relationship, you know that your arithmetic mean will be higher than your geometric mean. So look at the options and find out which one is lower than the arithmetic mean. That is most likely your answer. Let me rephrase it in another way. You're given a question that says that your arithmetic mean is 15, and then you're asked what is harmonic mean. There's nothing else to work with. Maybe you do not have a data set to calculate. And then you're given option of 23, 15, and then 12 to say which one is your harmonic mean. Because you know the relationship between harmonic, geometric, and arithmetic, you know that your arithmetic mean will always be higher than your harmonic mean. Clearly, that eliminates the 23. It also eliminates the 15, except all the data in your observation are the same, which leaves you with the 14. So what I'm saying is, even if you're given data, right, if you understand the relationship between the three means, when you're given options, you can tell which one is the right answer by just looking at the relationship and not necessarily through calculation. And I think I also mentioned this in the last class. Sometimes all you need to do is look at the relationships. Okay, so let's look at example 7. Now, in example 7, we've been given the PE of an analyst 10 favorite stocks for next year. And you know that PE is a ratio, right? So typically, if you're given this and you are to select which of the mean to apply, the best would be your what? Your harmonic mean, because this data is a ratio, PE ratio, remember? It's a number over another and over another. But regardless of that, you can calculate the three types of mean with this. And because we've dealt with this, we'll just run through this and just see how this is calculated. Now, for the arithmetic means simply the addition over the number of observation, which you can see in solution 1. Like I mentioned earlier, there's no twist to this kind of question. It's just what it is. And the geometric mean, you can see the multiplication of all of the means over the square root. Now, there is another option for calculating your geometric mean, right? Depending on if the one you remember faster, and depending on if you have flair for maths, which is using your logarithmic route. And in using your logarithmic route, the formula is exponential in log, right? And in this case, you multiply all of the values you have in your data set. You find the in log, then you divide that by the number of observation, then you find the exponential of that number. So you work backwards. So the first step is you multiply all your data, the value in your data set, you multiply all of them together. Then you find the in log
Hello,
of that
this
number.
for geometric mean.
Yes, this is for geometric mean. This is
Okay.
This is an alternative method of calculating geometric mean. So this does not change your formula like you have here. It doesn't change this. Where you multiply everything and then you find the 10th root or you find the n root. It doesn't change this. But here, what is being given here is an alternative way of calculating it. So depending on which one you remember faster or which one comes easy to you. For using the logarithmic option, there are 3 steps mainly. Multiply all your data set together. Find the in log. So step 1, multiply all data set together. Step 2, find the in log. Step 3, divide that by your number of observation. And then step 4, find the exponential of that number. So there are 4 steps. So if you list it that way and you can remember that steps, then you can use that to find your geometric mean. Then lastly is your harmonic mean. And like I mentioned earlier, you use the reciprocal of the data set you have been given. So if you go back to the data set, you can see for year 1, for stock 1 is 22.29. So you find the reciprocal. The reciprocal is simply 1 over 22.9. And then you add all of the reciprocals together. Once you have added all of the reciprocals together, right? Then you simply you divide that by a numerator. The numerator is your number of observation. In this case, is 10. So 10 divided by the summation of your reciprocals, right? And that's what you can see here. So your harmonic mean, therefore, is 10.81. What this question tried to point out actually is to see the relationship between your geometric mean, harmonic mean, and your arithmetic mean. Now, using the same data set, we arrived at 10.8 for harmonic mean, which you will notice is lower than 11.48 for geometric, which you will also notice is lower than 12.14 for arithmetic mean. This is the same observation that has been used, but you find out that they actually vary. The mean you calculated vary, and the lowest is your harmonic mean. So really, that's what this question tries to highlight, right? And so I would like anyone to try out the relationship for us. Now that we have assuming that you're given the arithmetic mean and the geometric mean, can you calculate the harmonic mean? Can you calculate the harmonic mean? Remember this formula: arithmetic mean multiplied by harmonic mean equals geometric mean squared. Okay, so again, so perhaps you should let's just plug in the numbers, multiply the harmonic mean by the arithmetic mean, and let's see if it's going to give us the geometric mean squared. Can we do that quickly?
Sorry, what's the figure for the arithmetic mean?
So I'm scrolling there now so that you see. Arithmetic mean is 12.1480.
12.14.
1480.
Okay, 1480.
Yeah.
Okay, harmonic mean.
Harmonic mean is 10 point.
11 point.
No, harmonic.
Okay.
Harmonic is 10.8142.
10.8142. Okay.
Yes.
11.46.
11.46.
Yeah.
11.46. Okay. Can you share with us what you did?
I multiply the harmonic mean and geometric mean, and I find the square root.
Okay. It gives you 11.446.
I use 12.1480 multiplied by 10.8142.
Yeah.
Then,
So whatever you get, you find the square root, right?
yeah, exactly.
Yeah. So and what you got 11.42 or 62. Is it 62 or 42?
11.42.
Let me do it again.
It's 11.46.
46.
11.446. All right. All right. Okay. So the idea really is that you can see that it is close to the actual geometric mean, which is 11.42. So that relationship holds. And I think I pointed out in my last class as well, in my previous class, that this relationship is not 100%. It's actually estimated. So you can use it as an estimation. What it means is that, as you can see, it's not exact. So it's not actually an exact calculation, but at least it will give you a number that is very close to your actual geometric mean. Okay. Thank you. All right. There are two types of mean that they are not very popular like the three we've talked about. And typically, these two means also came up as a result of outlier. How do we manage outliers? Like we have discussed, only the harmonic mean really managed outlier for us so far. And so what other practical ways do we have to manage outlier? So we have two other means we can calculate. We have the trimmed mean, and then we have the winsorized mean. The trimmed mean or on the winsorized mean. Now for the trimmed mean, it's as the name suggests, you trim it. So you have a data set with an outlier. What you do is that you can look at the most extreme value, you cut it off. And then the most extreme value that is the lowest, you cut it off. Now imagine that I have a data of minus 40 to plus 600, right? And then I have a lot of other data in between. What I would do is that I will cut off the plus 600, I will cut off the minus 40, then use the remaining one, use the remaining observation. Of course, what you will get would will not be, because you're not using all of the data, right? But what you will get will be much more reasonable as a mean than when you allow the 600 to stay and you allow the minus 40 to stay. So that's called the trimmed mean, in which you remove the highest number and the lowest number and then use the remaining observation. Now, for winsorized mean, is similar to your trimmed mean, but for the winsorized mean, rather than cut those numbers off, the highest and the lowest, you simply just replace them. So for example, if I have a data set that is, let's say 1 to 50, and then I then have 600, right? I have 1 to 50, then I then have 600. What I would then do in a winsorized mean, okay, so in a trimmed mean, I will remove 1 and remove 600. Then I will use between 2 and 50, right? Now, in a winsorized mean, I will change the 1 to 2. I will change the 600 to 50. So the 600 will take the value of the next one, which means before 600 is 50, right? And 600 is the outlier. So I will change that 600 to 50. So I will now have two 50s at the end of my data here. Then I will change 1 to 2. So rather than my data starting from 1 to 600 now, my data observation, I will now have from 2 to 50. So at the beginning of my data, I will have 2, 2, and at the end of my observation, I will have 50, 50. And then use that observation to calculate my mean. So that is the winsorized mean. And trimmed mean means I will cut off the 600, I will cut off the 1, right, and use the remaining.
So when you cut
Okay.
off the, sorry,
Go ahead.
can you hear me?
I can
Yeah,
hear
so
you
when
clearly.
you
Yes.
cut off the outliers, are you going to, so you are using the harmonic mean formula to compute,
So you
or
can use it.
anyone?
You can use anyone actually. I think the idea here really is outlier kind of skew, make your mean to be skewed, right? And so once you remove the outlier, you can then go ahead and actually use your arithmetic mean or your geometric mean. Because the harmonic mean, again, the main function of the harmonic mean is to help you to moderate the outlier. So if you have used your trimmed and your winsorized to take out the outlier, you cannot just go ahead and use your arithmetic mean or your geometric mean. It's fine. Is that clear?
Yeah, good.
Now, this is just a guideline in terms of how do you decide which measure to use. It's a guideline, Exhibit 8. Now, when you have your sample, which is typically the first step, you collect your sample. Now, do you want all of the values in your samples to be used? All of your observation? The 600, the 1, the -40. If your answer to that is yes, then arithmetic mean is what you should use. You could use the arithmetic mean. Again, it doesn't mean you cannot use all the other mean, but I mean, the arithmetic mean is like perhaps the simplest to use. If compounding, which means you have data sets that are compounded, over time, right? Then the geometric mean is the best to use for compounding. Now, when you have extreme outcomes, right, or outliers, then you can either use the harmonic, trimmed mean, or winsorized mean. Now, back to your question earlier, I think I didn't answer it correctly. If you use trimmed mean, you've already calculated the mean. So the mean you calculated is similar to your arithmetic or geometric mean. Do you get? So your question then would be, should I just do a simple average, or should I just do a geometric mean? I think it will be that you can do any, in my view. You can either use a simple average or use a geometric. But as long as you remove those outliers, whatever you get will still be kind of an average of your data set. Because remember that what you're trying to get is an average out of your data set. Okay. So that's a way to decide. Here's a question. So if one has the following return over 10 years, arithmetic mean return over 10 years is closest to. I've mentioned this before. You can see that this is the question at the end of discussing arithmetic, geometric, and harmonic. Yet you can see how the questions are coming. They are very straightforward. So do not expect any complicated question at this here. They will give you the data, they will ask you to calculate the arithmetic mean. And you just plug it in straightforward to the formulas. The geometric mean, the same thing. So this is to remind you of how the arithmetic mean or the geometric mean is calculated. And so this is, we've looked at the 3 types of mean, major, and then the trimmed and the winsorized mean to deal with outlier. Is there any question before we move to section 4? Any question before we move to section 4?
Let's keep moving.
All right, thank you. Okay, now we're getting to a session that is a bit it's not complex, but this requires you to patiently follow along here. Once you get it, you'll find out that it's actually simple. This is where questions, if they want to ask a question that is intermediate, so you have your simple questions like calculate the arithmetic mean, that will be very, very simple. But if they want to ask the intermediate question, this is the section where they will ask it. And this is looking at money-weighted and time-weighted returns. There are 2 types of return that you can calculate. the money-weighted return and the time-weighted return. And they are calculated differently, or the approach to calculating them are different. So let's look at it. First is the money-weighted return. So when we're talking about money-weighted return accounts for the money invested by the investor. It accounts for inflows and outflows of the monies invested by the investor. And your money-weighted return is also equal to your IRR. In fact, you calculate money return by finding IRR. That is the internal rate of return. Now, if you recall, what is your internal rate of return? Your internal rate of return is simply balancing your cash outflow and your cash inflow. So your internal rate of return is the return that equates your outflow and inflow, which means that gives you that makes your NPV 0. Now, NPV being your net present value. And how do you calculate NPV? Right? NPV is you discount your positive cash flows, you discount your negative cash flows, and you add them together. That's why it's called net. You add them together. So when you add your positive outflow and your negative cash flow together, it's called net. And because you have found the present values of those cash flows, you did not just add cash flows, you found the present values of those cash flows, right? So it is the present values of your positive and your negative cash flow that you've added together. That is why it is called NPV, net present value. And so when your net present value is 0, which means they equal out or the balance out. Your cash outflow, your present value of your cash outflow balances with your net present value of your cash inflow. Then you have a 0 NPV. What that means is that the discount rate, which you apply to find the discount for your cash outflow and your cash inflow, that gives you the 0 NPV is your internal rate of return. Now, so if you recall from your internal rate of return discussion, that is how it is set up. So for your money-weighted return, what you're then looking for is that IRR, to say that the rate of return that equates all the money you put out plus all the money you got in, the rate of return that equates it, which gives you a 0 NPV, is your internal rate of return. In other words, that is your money-weighted return. Okay, and so this is better explained from an example point of view. And so, so let's just follow. Now, take this as an example from your curriculum. Let's use that. Assume that an investor invests 100 euro in a mutual fund at the beginning of the first year, adds another 950 at the beginning of the second year, and withdraw 350 at the end of the second year. The cash flows are presented in Exhibit 10. First and foremost, when you're dealing with money-weighted return, the first step you must master is how to set up your cash flows, because it is then that cash flows you then plug in and calculate. So how do you set up your cash flows? First is understanding there is what we call the negative cash flow and positive cash flow. And the way you think about that is you are the investor. When you put in money into an investment, it lifts you. So look at yourself. It lifts you. Okay? So you take the position of an investor, right? So if I put my money in mutual fund, for example, that money leaves my pocket. So it's minus for me. Now, it's important to have this mindset, because you can then be thinking that, but it's my investment, so it's positive. No, it is negative because it has left my pocket. And once it leaves my pocket, it can either come back positive or come back negative. I have no control over if it comes back positive or negative. Do you get my point? So if I invest money in mutual fund, in the next period, it can be negative. It can go down maybe by 10%, or it can go up by, say, 10% as well. Therefore, the perspective you take is that of an investor, and any money you put in an investment is seen as a cash outflow. Any money that comes to you is seen as cash inflow, is seen as inflow. Understanding that for NPV, you need to find out outflows and inflows, find the present value of outflows and inflows, and then find the internal rate of return that equates both. And therefore, finding your cash flow is important. How do you recognize which one is negative cash flow? Any money that leaves you is negative. Any money that comes to you is positive. So let's go back to this example. Assume an investor invests 100 euro in mutual fund at the beginning of the year. Is that 100 euro a cash outflow or a cash inflow?
Cash outflow.
Correct. So you see, you take the position of the investor, and any money that leaves you is a cash outflow. And add another 950 at the beginning of the second year. Is the 950 a cash outflow or a cash inflow?
Cash outflow.
Outflow.
Good. And withdraws 350 at the end of second year. Is the withdrawal cash outflow, cash inflow?
Inflow.
Inflow.
Good. Now, you see, it's important to have it set up like this in your mind, because by the time you look at withdrawal, you would think it is minus, but to the investor, it's plus. So take the position of an investor and view it that way. That way, you're able to set up your cash flows correctly. The second thing you need to be able to do is period. When is first year? When is second year? When is third year? Right? Now, the rule is, it is assumed that any investment you make, right, at the beginning of the period is seen as being made at the end of the previous period, right? Any investment, any cash flow that appears at the beginning of a period is treated as a last year. Do you get my point?
Why is it treated as a last year?
Not exactly.
Okay, let me state.
You mean the cash flow that is invested at the beginning of the period?
No, let me put it in another way. Look at when the cash flow happened. It can either be positive or negative. We've established that your cash flow can be positive or negative, right? So
yes.
Just take it as cash flow now, right? Just think cash flow. Don't bother about if it's positive or negative. Positive or negative only affect the sign in front of it. Just what we want to establish now is, when does a cash flow happen? What period? We want to add periodicity to your cash flow. If you give me money, right, in January, if you give me money in January 1st, okay? If you give me money in January 1st, the rule is you treat it as I received it 31st December. So in that way, I will treat it as 2023. If you give me January 1st, I will treat it as I received it in 2023. I will not treat it as receiving it in 2024. Now, if I get any money I get at the end, or any cash flow, so let me use cash flow. Any cash flow that happens at the beginning of the period is treated as a last period cash flow. So if I get it at the beginning of the period, it's treated as last period cash flow. If I get it at the end of the period, then it is treated as that period cash flow. Now, what that means is, if you get a cash flow, or if a cash flow happens at January 1st, what period does it belong to? January 1st, 2024.
December 2023.
Good. It is treated as 2023, right? If I get a cash flow 24 December 2024, it's treated as what year cash flow?
December 2024.
Good. So that
2024 cash flow
is treated as 2024 cash flow. So that is the methodology to set up period. Now, the reason why
this example. Sorry.
Now, okay, let me repeat it. No problem. Let me repeat it. You are thinking of cash flow. Forget if it's negative or positive. Okay, for now, just think about cash flow. Any cash flow that happens at the beginning of a period, right, is treated as a last period cash flow. So an example would be, if a cash flow happens on January 1st, 2024, which period are you going to attach to that cash flow?
2024.
No, you apply 2023.
2023.
So, yes. Because because the cash flow happens at the beginning of 2024.
So I'm going to treat it as
2023 cash flow.
Like the previous period.
Exactly.
Or the past period.
Yes, the past period cash flow. Right? If the cash flow happens, let's say 24th December 2024, it is treated as 2024 cash flow. So if it happens at the beginning, it is treated as previous period. If it happens at the end, then it's treated as that period. Right? Now, why do we do this? Or why is this set up this way? It is set up this way so that time value of money can make sense. And if you've done time value of money, you would notice that there's annuity due or annuity, normal annuity, and all of that. Now, the essence is this. If you take a cash flow, let's use a cash flow of, say, January 2024, right? If you take a cash flow of January 2024, right? When is this cash flow going to generate return? It's going to generate return in 2024. That is the full period of 2024. Now, the way to calculate it is going to start from 0 to 1. So your last period is calculated as your 0, as the case may be. So you take it back 1 year. So if you take it back 1 year, so that becomes your year 0, which gives you the opportunity to say that you got cash flow. You always get your initial cash flow, or you always do your initial cash flow at period 0. That's where your cash flow starts from. It always starts at period 0, not at period 1, except you get it at the end of the period. But typically, you make your investment at the beginning of the period, which means you have to take it back to the previous period to give it an opportunity for it to grow from 0 to 1, which means you can then count from January to December, 12-month period. Then you can then say, if you have earned 50%, you can then say you earn 50% from year 0 to year 1, which will mark your first period. The reason why this is also important in setting up it, apart from the fact that when you look at your time value of money, you see that it's always indexed to 0, right? Is because mathematically, for the first period, the discount of the first period is always raised to power zeros. Let's say that discount rate is 10%, and your initial period cash flow is 10,000. If you recall how it is set up, it is 10,000 over 1 plus 10 into bracket raised to power 0. That is index period. Anything raised to power 0 is 1, which means 10,000 divided by 1 is 10,000. Which means at the time you're getting the money is complete at 10,000. So if you make an investment, if you start an investment with 1,000 or 10,000, at that date was given to you, the value is complete. It has not lost any value at 10,000. That is why your initial period is always correct based on that calculation, because anything raised to power 0 is 1. And when you divide that 1 at the denominator over your with your cash flow, you still get the same value, which theoretically proves that any money you get or any cash flow you get on the very first day or the very first period does not lose value on that day. But subsequently, it loses value. 1 week after when you apply the discount rate, it's no longer 0. 1 year down the line, it is no longer 0. But if you use 1, for it, which means you then say 10,000 over 1 plus 10% into brackets raised to power 1. The present value is going to be 9,000 something, right? If you use 1. That is why it's important to use 0. That is why you index your first cash flow always to 0. And the implication of that is when you get a cash flow, you index it back as if you received it the previous period. And the previous period is always 0. That is where you're starting from. Year 0. That is your first. That is when you're starting, rather. And then you move from 0 to 1. And then you go on subsequently. I think there is time value of money as part of this curriculum. I think it's the next. When we get to that, I would break this portion down a bit more further so that you will see why it's important you set up your cash flow that way. Now, what you need to understand and remember right now is, how do I set up my cash flow? Period 0 is when your initial cash flow happens. It is always period 0 because nothing has happened at that point. Subsequent periods can then, have value. Now, so in our example, assume an investor invests 100 euro. This is indexed at 0. That is the time. That's always the time an investment starts, period 0. In the first year, add 950. So this will be indexed to 1. That's the first year. Now, this 950 is seen as received at the end of year 1. At the end of year 1. Let me put it back an example. If I got for this client now, this client made an investment of 100 euro in January 2024, which means that 100 euro will be indexed to 0, right? So 100 euro will be year 0 cash flow. The 950 added in year 1, that is December 2024, will be indexed year 1 cash flow. And then in the second year, it made the withdrawal of 250. So that will be indexed to year 2. But again, how do you also index? Depending on the time where the cash flow happens. So look at the time where the cash flow happens. If it's at the beginning, take it to the previous year. If it's at the end, maintain it in that year. So with that understanding, let's now go to, how do you set up using actual scenarios? Any question?
I think I'm fine. Let's see if we go to it.
All right. So here is the setup. Like I mentioned earlier, you need 2 things to set up. One is how do I determine my cash flow? Is it positive or negative? Second, how do I set up my periodicity? So look at this table. Now, this table achieved one thing. So because numbers has been given, we really want to trace back what really happened from an actual point of view, so that when we then put this into calculation, we will know if we are correct or not. So that's what this table achieves. So let's follow the reasoning. Balance from previous year, 0. So from the previous year, there was no investment. New investment by investor. So at the start of the year is 100. At the start of the year, okay? Now, this is year 1. So at the start of year 1, it's 100. Net balance.
But you said it will not be reported in year 1.
No, don't worry. We'll get to that. I've told you the purpose of this table. When you want to plug it into your calculation, you will see how it is done. This table is set up. It's like when you have when you are doing accounting. When you are doing accounting, you won't say 2023. Do you get? But when you are doing your NPV calculation, that's how you do it. But don't worry, just follow the table. This table is to help you understand what happened. The initial cash flow was done in January 2024. There's no question about it. But when you're applying it in your formula, you index it to 0. That's the initial one. That's the point. But for the purpose of this table, don't worry. We are still. So take year 1 at 2024, which will still make sense. So understanding that this happened in January. But don't worry, you will see how it is set up later. Net balance at the beginning of the year is 100. Investment return for the year. So investment return for the year is 50 minus 50%, which means the investment lost 50%. Now, if the investment lost 50%, it means that your gain or loss is 50 euro. At the end of the year, you will be left with 50 euro out of your 100 euro investment at the beginning of the year. Now, you take this 50 euro, that becomes your balance from previous year in your second year. So that becomes this in your second year. And then in that year, you added 950. You added 950 to it, right? So this is the amount you added, 950, giving you a total of 1,000, right? So you have 1,000 to invest this year. In that year, you gain 35%, which means you gain an additional 350 on your 1,000. At the end of the period, and that same period, you made a withdrawal of 350. So you took out 350, you made 350, you took out 350. At the end of the year, your investment will have a balance of 1,000 euro. In year 3, you will start with the previous year's balance, which is 1,000. You did not add any money, so it's 0. So the total amount of money you have to invest is still 1,000. And in that year, you made a return of 27%, which means you made 270. You made 270 extra. The balance at the end of the period, when you then cash out, is 1,270. Okay? Which means for this client that we've talked about, at the end of the period, he's going to get 1,270 back from his investment. Remembering that he started with 100, added 950, took out 350, and then at the end of the period, still got out 1,270 out of the investment. Now, remember this. This cash flow, everything we did here is based on this example, right? It's based on this example. So let's go. The only thing that has been added here is the investment return per year. So 50 minus 50% in year 1, 35% in year 2, and 27% in year 3. Now, the internal rate of return, sorry? You have a question?
No. I said 27% in year 3.
Yes, 27% in year 3, correct. Now, the internal rate of return, this is the formula for your internal rate of return, which is cash flow at time t divided by 1 plus IRR at time t, right? Then aggregate that. The aggregation, the t sigma t is equal to 1, means that you aggregate that. That's how you, because you aggregate it, that's how you get your NPV equals 0. So what we're saying is that your NPV equals 0. So the IRR that makes your NPV 0, that's what we're trying to find, that IRR. Now, but then how do you then set up your cash flow? A cash flow can be positive or negative. We've talked about it. And we've talked about which cash flow is positive and which cash flow is negative. So you know that the 100 you put in initially is negative. The 950 you added is negative. The 350 you took out is positive, and then the final cash flow is also positive. Okay. So how do we then set up the cash flow as where each cash flow or each flow? Now, here's the point I was trying to make earlier. Cash flows are expressed as follows, where each cash inflow or outflow occurs at the end of the year. Thus, CFO 0 refers to the cash flow at the end of year 0 or the beginning of year 1. So you see, if a cash flow happens at the end of year 0, it stays in that year. Or if it happens at the beginning of year 0 or year 1, it is happening at the end of year 0. Now take it this way. If I bring in money December 2023, let's say 29 December, and I bring in money 1st of January, what's the difference? There's really no difference. So I better treat it as if I brought it at December 2023. Because both the one I brought December 2023 and the one I brought 1st of January is going to count the next 12 months. That is why you zeroize that. And that's why I explained earlier. If your cash flow comes in at the beginning of the year, you index it back to the previous period. Okay? So you can then see that because this cash flow came at the beginning of year 1, so go back to your table. Because it came, the 100 came at the beginning of year 1, it is seen as previous year's cash flow. And previous year will be 0, right? So it is CFO 0, right? Now, the 950 came in at the beginning of year 2. So it's taken as year 1, is indexed back the previous period. So you can see that the 950 happened at the beginning of year 2. So it is indexed back to year 1. So it's seen as, you can see that it's stated here at CF1. So it's stated as year 1 cash flow, right? Now, for the withdrawal happened at the end of the year, at the end of year 2. So it is seen as year 2 cash flow. Okay? And then year 3, which is the end of the investment period, the cash flow happened at the end of year 3, right? So it's still seen as CF3, that is cash flow at year 3. So let's go over it again. If it happens at the beginning of the period, index it 1 year back. If it happens at the end of the period, it stays, right? Cash flow can either be inflow or outflow. If it is an investment, then it is outflow. If it's withdrawal, then it's an inflow. Outflow is negative, inflow is positive. Maturity value of investment is positive because now your money, all your invested money is coming to you. So it's cash out inflow. That's why the CF3 cash flow is positive because now your money is coming back to your pocket. The balance of your money, 1,270, is coming back. The 1,350 you took came to your pocket, so that is positive. The 950 you invested left, that's negative. The 100 you invested left, that's negative. So you can see that is how to set up your cash flow. And once you have set up your cash flow, I have a question. Please go ahead.
So what if there were additional or more cash flow within the year 1?
Within year 1, it's fine. Determine when it came in. If it's at the beginning of the period, right, take it back. If it's at the end of the period, it stays. If it's an inflow, if it's an addition to the investment, it's negative. If it's a withdrawal, it's positive. For example, this client withdrew 350. He could have come back again and withdraw another 200, and then come back and withdraw 50. In that case, as long as the cash flow is within that period, you can aggregate all of the cash flows for the period. Now, and you will see how that is done. You aggregate cash flow for periods. So, for example, if there were multiple investments in a year, at the beginning of the year, or at the end of the year, or within a year, you aggregate it. So, for example, let's say that this client brings in another 100 or another 200 in that same CF1. You will simply do minus 90, minus 100, minus 200, which will now give you minus 1,000 something. That is what you would then use for your calculation. So aggregate, as long as you have categorized them into the periods, aggregate all of the cash flow per period, so that at the end of the day, you only have one cash flow per period. That is, you will have aggregated all of the cash flows either in and out for that period. That's what it means. Is that your question?
Yeah, it's good.
Okay. Shortly, we will see another question that we can use to buttress that. Now, so after you have decided your cash flows and for each of the period, the next thing is to then plug it into the formula, which is CFO 0 over 1 plus IRR raised to power 0 plus CF1 over 1 plus IRR raised to power 1 plus CF2. Now you already have your CFO1, CF2, CF3, CF, which is cash flow year 0, year 1, year 2, year 3, and you can plug that. And then what that means is you then need to find the IRR. Unfortunately, the IRR is such that you find it through trial and error. You find it through trial and error. In
What
the
do you mean by that?
CFA, there is no formula per se for calculating IRR. You have to plug in different interest rates to find out which one will give you the value of 0. Now, the way
Can't
to
our
make
calculator derive it for us?
it can. I think there's an IRR on your calculator, so you can use it to calculate it. There's an
Can you
IRR
put
on
us
your
through?
I don't have my calculator here.
Instead of gambling the exam on you because of time.
No. So, in fact, so the thing is, gambling in the exam hall, it's not likely. I would even prefer that you solve it rather than use calculator, because unless you've mastered how to use calculator, you may make a mistake in when you're typing in your numbers, which will give you a different answer. But if you calculate it, the likelihood of having an error is maybe minimized. Now, the way to calculate this simply, or the easiest way I would suggest you follow to calculate your IRR is understand how IRR works. And this is how it works. When you reduce IRR, your NPV increases. When you increase IRR, your NPV reduces. Right? Now, you're looking for something that is...
They have inverse relationship.
Yes, they have inverse relationship. If you look at how the formula is set up, it is set up to be equal to 0, right? Which means that everything must evaluate to 0. Now, you will be given 3 options in your exam. You'll be given 3 options in your exam. If you're given 3 options in your exam, pick the middle option. That is, don't pick the largest, don't pick the lowest. Pick the one that is neither the largest nor the lowest. So if you have 3 options, 11.2, 12.7, and 15.1, pick 12.7, right? Then plug that 12.7 into your formula and calculate it, right? Once you calculate it, you will get a value. That value can either be greater than 0 or less than 0, or equal to 0. If the value is equal to 0, then it means that that is your answer. If the value is greater than 0, it means that the actual IRR should be higher than what you picked. In which case, you pick 12, and the value you got is higher than 0. So it means that you should go for 15, because when you pick 15, it will make that value come lower to 0. Therefore, it means that 15 is your answer. You don't need to calculate it anymore. But if the value you got is lower than 0, then it means you need to pick a lower IRR, which means in this case, you have to pick 11. And you don't need to calculate it again. That is your answer. Do you get it?
Okay, but in this case, can you just explain how they actually just went about it in the example? Yeah.
How they went about
How
it?
did they get the 26 points?
Yeah, exactly.
So the way they got the 26 point really is through what you call trial and error. So the way it works is this: you pick a random IRR. Typically, we'll say pick a 10%. It's a random number, but start with 10%. Now use 10% to solve this. Depending when you use 10% to solve this, that is, you plug 10% into this calculation. Where you have
So that would
IRR,
be
you put
1 plus 10%.
yes, that will be 1 plus 10% raised to power. So let me first explain the first. You can see that minus 100 is raised to power 1 here. The reason why you see 1 in the denominator is because anything raised to power 0 is 1.
Is 1.
Yes, anything raised to power 0. So for that CF1, so for your CF0, you will notice that if you notice that the first CF here, CF0 over 1 plus IRR raised to power 0. Anything raised to power 0 is 1. That is why when you see under, they simply wrote minus 100, which is cash flow, over 1. Because your 1 plus IRR raised to power 0 as already, it doesn't matter what IRR you put, it's going to be 1. That is why you see the first one as minus 100 over 1. Is that clear?
Yes.
Then you go to CF1. CF1 is minus 950 over 1 plus IRR raised to power 1. So let's use 10% as an IRR, for example. So what it means is that for everywhere you see IRR going forward, you plug in 10%. So it will be 1 plus 1 plus 0.10. So you have 1.10 at the end of the day for under raised to power 1. So when you solve this, you will get an NPV. Most likely you will get an NPV that is significantly higher than 0. Now, because you got an NPV that is significantly higher than 0, pick another IRR that is greater than 10, significantly greater than 10. Take 30%. So plug in 30% into this formula. You will find out that you will get an answer that is significantly lower than 0. Then the next thing to do is to do what we call interpolation. Interpolation is the higher IRR, right, plus the higher NPV over the lower NPV, okay, multiply by the lower IRR.
Are you writing somewhere? Because I mean,
Let me
if you are
write
using
it.
your tab or something, we can't
No,
see.
I'm not using my tab. Let me write it out.
Okay.
There's a formula, but it's just that it doesn't. There's no shortcut. But perhaps maybe that your option of your. Oops, I don't have. Let me see. Please hold on. Let me get a pen.
Because I'm wondering if we use 10%, for instance, would have 1.1 for the year 1. That's 950 minus 950 over 1.1.
Yes.
Right? So, and the next one will also be like 1.1 raised to power 2.
Yes.
That's so if you add everything together, I'm still wondering how you now get 26.11.11%.
No, you are not going to get 26 points. You are going to get an NPV. You're going to get a value. All right. So guys, let's do it this way. Let's just calculate it. Okay.
Let's use
I want
10%.
someone to use 10%. I want another person. So let's assign it. Emmanuel, Bolaji, please use 10%. Bolaji, use 10% for the calculation. Emmanuel, use 30% for the calculation.
The
Then
entire
give us
cash
the
flow.
number. Eh?
The entire cash flow. And see what we get.
Yes. So in that, in this, I'm highlighting it now. So plug in 10%. So plug in 10% where you have IRR. Then Emmanuel, plug 30% where you have IRR.
30%.
And calculate it.
Okay.
Yes, 30. So I'll calculate it. So and let's see your answers.
So for 10%, I have 279.7.
279.7.
0.7. Yeah.
Okay. 279.7. 279.7. Great. So let's keep that number. Emmanuel, have you gotten the value for 30?
I'm adding up.
Okay.
I got 732.45.
732. 732.
0.45.
732.45 at 30%.
Yes.
That cannot be correct. At 30%, it will be negative. You know why? At 26% is 0. Anything higher than 26% will be negative. Anything lower than 26% will be positive. So Bolaji can be positive because it's lower than 26%. But because you are higher than 26%, because 30 is higher than 36%, it has to be negative. So calculate it again. Did you use the minus 100? And did you raise it to power? Remember the raised to power
Yeah, I did
under.
raise to power. Because 1.3 raised to power 1, here 1.3 raised to power 2, here 1.3 raised to power 3. And I did the inverse to multiply by what is on top.
And then you added it all together.
Yeah, 1.3 inverse multiplied by.
What did you get for the one? Okay. What did you get? Okay, let's do it together. I don't think the 30, I don't think it's correct. So let's do it together. 1.30 raised to power 1 will still be 1.30. So the inverse of it multiplied by 950 is what? Just give me the figures.
Minus 736.
Minus 736. Okay, let's put
No,
that
it's
down.
730.
7.652.
It's
Sorry, it's what? 730.
730. Not 736.
Minus 730.
Minus 730. Okay. Then let's do. Okay, so let's do for the 350. 1.30 raised to power 2 times 350. Then inverse times 350. It's what?
I got 207.1005.
Okay, 207.1005. All right.
Please confirm it.
Yeah.
What did you get?
207.
207. Okay. Then 1 plus 1 plus 1.30 raised to power 3 multiply the inverse multiply by 1 to 70.
What?
What did you get?
578.0609.
578.06. Okay. Now add all of that together. What did you get? What would you get?
Minus 45.
Minus 45. Okay.
Yeah.
Which is that what you got to, Emmanuel?
Oh, maybe when I was doing my addition, exactly all the figure I got. Let me do it again. Oh, sorry, I must have not put minus somewhere.
Okay. Then did you
minus,
add the
sorry, minus 45.6.
Okay. Did you add the 100, the minus 100 at the beginning? Did you include that as well?
Yes, yes, yes.
All right. Okay. So you can see that it is you can see that it's negative, right? So now to
Yes.
calculate the IRR, you can write down this formula and then use it to calculate. The lower discount rate, in this case, the lower discount rate we used was 10. So lower discount rate, that is 10, plus now the MPV when we use the lower discount rate, I think 270 something, right? That MPV we
279.
got 279. Okay.
279.7.
Okay. Now that's 279 into bracket 30 minus 10. So you do 30 minus 10 in bracket beside 279.
Oh, beside 279.
Yes, that is the
No,
numerator.
can
You say
you just
10%
call it
plus
again?
279.70, then 30 minus 10.
Okay,
No,
put
call
it
it
this way.
again. Just
Let me call it again. 279 multiplied by open bracket 30% minus 10% close bracket.
Okay.
All over open bracket 279 minus 45 close bracket
279.
minus
279.70.
yes minus 45. So it's supposed to be minus 45, but because 45 is negative, so it will be minus 45. Do you get?
Okay,
Then
45.6.
yes, then all of these things, the numerator and the denominator that I've mentioned, enclose it with brackets, both the numerator and the denominator. Then in front of it, add plus 10%. So the formula then becomes 10% plus, open a big bracket. The numerator of that bracket will be 279 multiplied by open bracket 30% minus 10% close bracket over.
I'm lost.
Tell me, read out what you've written. What's the
Okay.
formula
For
you've
the
written?
numerator,
Yes.
you said 10% plus
No.
279.70
The 10% is standalone.
is standalone.
Yes.
It's neither a numerator nor denominator. It's standalone.
No. So
Okay.
10% plus, then you then have a big bracket that has a numerator and a denominator.
Oh, okay. I got it now.
Yes. Then the
Oh,
numerator
10%.
is plus
279.70. Open
yes.
bracket 30% minus 10%.
Yes.
Then divided by
Yeah.
279.70 minus the open bracket minus 45.6. Then
Exactly.
a big bracket to close both the numerator and denominator.
Exactly. To solve that, what do you have? Solve that and
you
then
got 27.
you got what?
27.
You got 27. Good.
Yeah, I think
You
it's
can
because I
see
ignored some decimals.
it's fine. So the idea really is that you can see that your 27 is close to your 26.11. So with that is your IRR. That is what you've done is interpolation. And the reason why you got 27 really, right, is not necessarily because of even the decimal. It's because the range you calculated with. For example, if someone had picked 12% and 28%, they will get something that is closer to 26 more than you. Do you get? So because you went for a wider range, we picked 10% arbitrarily. We picked 30% arbitrarily. So another person could have picked 12% and 29%. Another person could have picked 14% and 28%, or 14% and 36% arbitrarily. It doesn't matter. That's why you find out that. So as a matter of fact, you won't get an exact number, but you get something that is close to the real IRR. But the way to then check if that is the IRR really is if you plug your 27 into this formula, you will realize that what you will get will be closer to 0. It won't be exact 0. It will be closer to 0. It will still be slightly lower than 0. That is, it will be minus, maybe like -2, which means you need to then reduce that 27 a bit, maybe to 26. This 26.11 is the only value that will give you an MP or an IRR of 0. But again, the calculation you've done now is okay. At least in your exam, they will not give you options. They will give you options that are wide apart. So for example, you will see a 26.1, you will see a 35, you will see like a 15. So clearly you will know that the one that is closest is the 26.11, and you still be correct. Because they understand that for you to get IRR is interpolation. And as long as you interpolate and different people will use different interpolated numbers, the IRR they will get will be slightly different. And so that would always be accounted for in your options, in your answer options. So the only option you will see that is actually close to 26 will be around that 27 or 27.5. That way you can still, your answer will be 26 or 27, or even it could be 26, it could be 27, it could be 27.5, but in your options you will see 26.11. So that will be the closest. Your question will also say is closest to. So you can simply just select that as the closest to, and you will still be correct. Because the other options will be wide from 26. Trust me, they will be wide. So you will know that those are not the correct answer. So really, that's how to calculate your IRR. You interpolate it. Now, as mentioned earlier, there is an IRR formula on your calculator. Maybe when I come for the physical class, we can then demonstrate that, can then show you. But again, it's something you can even Google it. There's a way how to use your BI to calculate IRR. You can just check it and follow it and see if you get it. The other option is Excel. You can use Excel to calculate your IRR as well. So I think if you go to formula, if you put internal rate of return, it will bring out the parameters, and if you put in the parameters, you'll get your IRR as well. So there's the Excel option, there's the calculator option. But if you have to calculate it yourself, do interpolation, and you'll still be correct. So that's how the IRR is calculated.
Well, this is so much to do in the exam in 3 minutes.
In interpolation.
Yeah, I mean this whole computation of IRR.
I'm giving you the shortcut now. The shortcut is this. Pick the middle number in your option, in your answer options. Plug it into your formula. Calculate it. If it's higher than 0, pick the lowest. If it's higher than 0, sorry, pick the higher of that number in your option, and you are correct. If it's lower than 0, pick the lower of that number in your option, and you are correct. So if in your option you have 11, so let's say, for example, in your option, you have 1.2, 15.4, and 21.7. Take only 15.4, calculate it. It's either it gives you 0 or it gives you a positive or a negative number. If it gives you 0, then it means that 15.4 is your correct answer. Just pick it and move on. If it gives you an answer that is greater than 0, then it means that the higher number, which is 21.6, is the correct answer. If it gives you a value that
you mean that the options, you plug it into this formula?
Into this formula, yes. Just take one of the option and plug it into this formula. So all you need to do is calculate it once. So for example, in the example I've given, take the 15.4 and substitute it into this formula and calculate it. It will give you either of 3 options. Option 1, it can give you 0. If it's 0, then 15.4 is your answer. If what you got is more than 0, it means that 26.1 is the answer. That is the one that is higher than 15. If you get something lower than 0, it means 11.4 is your answer. the one that is lower than 15. So all you need to do is calculate, you just calculate once. You don't need to calculate.
Yeah, I got it.
This interpolation. The interpolation you use. This is not it's a you know that there is no way to calculate IRR directly. No, they just showed you the answer. So don't worry, it's normal. Okay, so is that clear?
Yeah, we're good.
Yes.
Now let's look at another example. In this example, we now want to consider dividend payment, right? Dividend payment. There are other options that can come up. That could be dividend payment, bonus payment, you know, and so. So this next question, you know, then brings in dividend payment and see how we solve that. The key thing that we have learned so far, and I want you to have a good grasp of, is number one, how do you identify cash flows? Number two, how do you put your cash flow into periods? And then number three, set up your formula. And as we have demonstrated, once you set up your formula, it's then now left for you to find a way to calculate your actual IRR. But if you do not set up these things properly, you will not be able to calculate an accurate IRR. So step one and step two is important. Now let's go to this question. This is perhaps a way to introduce a little bit of complexity, but it's not difficult, and we will see how that works. Now, this is an example of a dividend-paying stock. Now, consider an investment that covers 2-year horizon. At time t is equal to 1, an investor buys 1 share at a price of 200. So they've made it easier to tell you t is equal to 0, which is the time at which the initial investment was made. So they made it easy, so you know that at least that is CF0. Now, so an investor buys 1 share at 200. At time T1, he purchased additional share at a price of 225. At the end of year 2, that is T2, he sells both shares at a price of 235. During both years, the stock pays a dividend of $5 per share. The T equals 1 dividend is not reinvested. So Exhibit 11 outlines the total cash inflow, and cash outflow. Now let me ask a question to the general house. Dividend payment, is it a cash inflow or cash outflow?
Cash inflow.
Cash inflow.
Cash inflow. Good. Because as an investor, it came back to you. Now, if that dividend was reinvested, is that a cash inflow or a cash outflow?
Outflow.
Good. What that means is that it got to you, but you put it back into the investment. So there's going to be in and out. So it's going to net off, essentially. Okay? So when it comes to dividend, the question you want to ask is, was it reinvested or not? Because if it was reinvested, the treatment will be different from if it was not reinvested. So you have to be clear about reinvestment. The question will state clearly if it was reinvested or not. Okay, so in this question, we were told it was not reinvested. Now let's see how the cash flow table was set up. In time T0, 200 outflow, 200 to purchase the first share. In T1, you purchased additional share, which is 225. Okay, both are outflows because money left you. In T1, dividend was paid, which means money came to you. Therefore, that is an inflow, and it happened in T1. In T2, you also got another dividend, okay, which is paid to you. But remember that you now have 2 units, and dividend is paid per unit. So these are very simple things you need to think about. In the first year, you only have 1 unit of share, and so your dividend is $5 for 1 unit. In year 2, you now, because you purchased an additional unit at the beginning of the year, so at the end of that period, you will have 2 shares, and each share pays dividend of $5, which means you are going to have a total dividend for the second year of $10 because you now have 2 units. Do you get? And that is your T2 dividend, $10, which is $5 per unit per share times 2 shares received. And at the end of the period, you sold the two shares you have for $235, which means you got an inflow of $470 at the end of the period, at the end of year 2. Is that clear? This breakdown, is it clear to everyone?
Yeah, it's clear.
Please, if you have question, please state it, because this is the complexity they can introduce. But when you work it out this way, it is easy. When the cash flow happens and what type of cash flow it is. So we've seen that done here. This first
I want
cash
to
flow
ask,
yes.
if the $5 dividend was reinvested, are you going to treat it as
good? If the $5 was reinvested, think about it. If the $5 was reinvested, okay, what would happen? It means reinvestment means that it will have been used to buy an additional share. Remember that when you say you reinvest something, you plow it back. Plowing back means you will use it to buy an additional unit. That's how it is done when it comes to stocks, right? So let's say that.
Yeah, so are you going to?
Am I going to what?
So is it like an inflow and an outflow, or outflow and inflow?
It's going to
or
net
just
off.
Disregard it.
It's going to net off. It's going to net off.
Yeah, okay.
You can disregard it, but then it has implication on the number of stocks you have.
Number of shares.
Number of shares you have. So let me use an example.
Just treat it as inflow and outflow.
You can treat it as inflow and
for the
outflow.
cash flow, it is zero rise.
It is
but
zero
number of
rise.
shares will move up.
But your number of shares would change because you will have used it to buy an additional share. So in this case, for example, you no longer have 2 shares, you probably have 3 shares, depending. Do you get? So you then have to consider that when you're doing your final calculation. So let's say, for example, that the dividend reinvested, this dividend was reinvested, and let's assume that is the amount reinvested is up to buy a new share. What it will mean is that at the end of the period, you will not have 2 shares, you have 3. That is the 2 shares you bought plus the share you bought through reinvestment. That way, your total number of units of shares would change. But in terms of your dividend, it is an in and out. It will have no effect on your calculation. It will zero-rise actually. But it's going to have effect on the total number of units that you used for your calculation. That is if the dividends were reinvested. Is that clear?
Yeah, good.
Okay. Now, once you have set it up this way, the next thing to do is, I've mentioned this, is to aggregate your cash flows. That is, the cash flow that happens at the same period should be netted. That is, should be added together. Now, for period 0, there's only one cash flow, which is 200. So we know that your CF0 is 200, minus 200 rather, because it's outflow. For period 1, you have an outflow of 225, but you also have an inflow of 5. So your CF1 will be minus 225 plus 5, because the 5 is an inflow. Your 225 is an outflow. So that will give you
220.
Minus 220, exactly. So your CF1 will be 220. Your CF2 will be the aggregation of your dividend and your final value, which is 470 plus 10, which is 480. So that will be your CF2. So at the end of the period, when setting up your calculation, you have CFO, which is minus 100, minus 200, CF1 minus 220, because it has been netted, and then CF2 would then be plus 480. That is the cash flow you will use for your calculation.
Plus what?
Plus 480 for CF2.
Okay,
which
470
is
plus 10.
Plus 10, yes. Is that clear?
Yes.
And that's what they did here. So if you look at it, you will see the CFO1, CF2, CF3. That's what they did here. That's how you arrived at those cash flows. Are we all clear how we got here now? There's no hurry. The main point in money weighted return is being able to arrive at your cash flow. In fact, the question can just be, what is your cash flow for period 2? Which means all they will ask you is to identify what your cash flow is. But of course, they will have put in some questions like dividend, like withdrawal and everything for you to arrive at that. Do you get? So be very clear in your mind that you can set this up to this point. You can arrive at your cash flow for each period. Because arriving at your cash flow for each period correctly is your key to getting your answer. If you do not arrive at it correctly, your answer would always be wrong. So everyone, is it clear how we set up to this point?
Yes.
Okay, good.
Yeah, we good.
Once you get, sorry?
Yeah, we are fine.
Good. Once you get to this point, all you need to do is then to plug these figures into your calculation. And I've told you what to do. Just pick one of your answers, the middle answer, plug it into this, calculate it, and then decide which one is the correct option. Okay? Maybe in the practice question, we'll see a question we can use to demonstrate that. Okay. I would I'm going to skip these other ones. Essentially, is just explaining the IRR and the money weighted calculation. Really just to prove to you that this IRR calculation is correct. That's what all of this explanation is doing. So let's move on. Let's do example 8. Look at this example, right? I would like everyone to try this example. What I want you to be able to do is to be able to set up your cash flow properly. Okay, so let's delve into this very well. Uli Lohman and his wife Suzanne Lohman are planning for retirement and want to compare the past performance of a few mutual funds that they are considering for investment. They believe that a comparison over a 5-year period would be appropriate, right? They gather information on a fund they are considering, the Rain Valley Superior Fund, which is presented in Exhibit 12. So in year 1, asset under management up to year 5 is given 30, 45, 20, 50, 25, and then 35. And then you have the annual returns as well. You have the annual returns. Then the Lomas are interested in aggregating this information for ease of comparison with other funds. So they want to aggregate for ease of comparison with other funds. So then they set it up this way. They set it up this way. All right. So Rain Value Superior Fund annual returns and investments in euro. Okay. So they set it up this way. And the reason why they set it up this way is so that they can break it down. so that they can break it down. So looking at the information in Exhibit 12, now let's look at Exhibit 13. And let's walk through Exhibit 13 step by step. Okay? Exhibit 13 step by step. Okay. Now, for Exhibit 13, balance from previous period is 0. So at the beginning of the year, so this is year 1. So typically you will say that this is TF0, right? But let's just walk through this, right? This is let's just walk through this table. So at the beginning of the year, the fund asset under management was 30, right? Now, and we were told that it earned an annual return of 15%. So the annual investment return was 15, which you can see here. 15% of 30 actual is 4.5, which means it should have ended the year at 34.5, right? So the balance from previous period was 34.5, which is shown here. Under year 2, opening balance for year 2. But we were told in the table above that the asset under management for year 2 was 45 million. What that means is that new money must have come in. Because if it opened, if you closed last year at 34, and you're telling me that the asset under management this year is 45, then it means additional money came in. So how do you derive the additional money that came in? It will be 45 minus the 34.5. And that's how you derive the 10.5. So in the table, we're not given, but you can see how that has been derived now. That is inflow into the fund. Inflow, because new money came in into the fund, 10.5. So at the end of the year, so the net balance at the beginning of the year is 45 that was invested. Now, that year, the investment ended minus 5%. Minus 5% means, or 45 is minus 2.25 in USD. When you take that out of the 45, it means that the balance at the end of the period will be 42.7 at the end of the year. Now, this becomes the opening balance for the third year, which is what you can see here. Opening balance for the third year, 42.75. Right? Now, but we were told that year, the assets under management was 20. So we opened the year at 42, but we're told that it's only 20 that was managed, which means withdrawal must have taken place. And the difference between 42 and the assets under management will be the amount of withdrawal. That is how you arrived at this minus 22.7. So minus 22.7 was withdrawn from the fund. Okay, giving us an asset under management at the beginning of the year of 20. That same year, the investment earned 10%. 10% of 20 is 2. So it means that the fund closed at 22, right? Now, that becomes the opening balance for year 4, 22. But we're told that the asset under management was 25, which means an additional money must have come in, which means 3 million must have come in as additional investment to make it a total of 25. Now, that total of 25 was invested that year and earned 15% return. 15% of 25 is 3.75, which means that the investment would close at 28.75. Now, this 28.75 becomes the opening balance for year 5, which we have here. But we were told the asset under management was 35 million, which means additional money must have come in. And the additional money that came in, if you calculate it, that is 35 minus 28.75 is 6.25 to give you asset under management of 35. That year, the investment earned 3%, and 3% is 1.05, which means the investment will close year 5 at 36.05. What this exercise enable you to do is, even when information are not explicitly stated, can you derive withdrawals and additional investment just based on the information you're given? That's what this table has done. We were given asset under management and the return per year. And using that, we can actually interpolate or derive the actual amount of withdrawal each month, each year or each period, and actual amount of additional funds investment each period. And that's what this has enabled us to do. Are we clear?
Yes.
Okay. Question 1 says, compute the fund holding period return for the 5-year period. So I want to believe at this point that you can still remember your holding period return calculation formula. I've already scrolled to it and it's seen 1 plus R1, R1 meaning your return for year 1, 15, plus 1 plus R2, your return for year 2 is minus 5. So 1 plus minus 5 will give you minus 95. And that's why it sees 0.95. For year 3 is plus 10%. 1 plus 10 will be 1.1. For year 4 is 15, so that will be 1.15. And for year 5 is 0.03, which is 1.03. Everything minus 1. So when you multiply all of this together and you deduct 1 from it, that becomes your holding period return. And that is 42.35%. That's your holding period return. So the holding period return for the Rain Value Superior Fund is 42.35%.
Sorry for bringing you back. I wasn't in class when you were treating this.
Yes.
This R represents 15% in year 1.
Yes.
Why R2 represents, okay, this is minus 5. Why did you put 95 here? Scroll up.
The formula, look, the formula is this. 1 plus R1. R1 is what? 15. So the way you set it up is 1 plus 0.15, right? So that will give you 1.15.
Exactly.
That is for R1. For R2, R2 is minus 5, minus 5%. The formula does not change. It's still 1 plus minus 5.
Yeah, it will be 0.95.
So it will be 0.5 exactly, because it's a negative sign. So that's how that was, yeah. So that's how that was right. Now compute the fund's arithmetic mean annual return. I think this should be easy. You simply add all of that together and divide by 5, which is what has been given here. Okay.
But you told us that if we see rates, we should use harmonic mean.
If you see rate,
if data is given in percentage, in rate.
If it's given, no, if it's given in ratio. If it's given in ratio, yes.
Okay.
Yeah. Your data typically will be given in percentage anyway. So it's not rate, it's ratio. If it's ratio, that's when you should use harmonic mean. Or when you see it's given in average, so you should use harmonic mean. Now, compute the fund's geometric mean annual return. I used to remember how the geometric mean is calculated. 1.R multiplied by 1.R2 multiplied by 1.R3, then all raised to the end root of that minus 1, which again you can see is 7.32. If you remember how the geometric mean is calculated. So far, are we good? Are we good with arithmetic mean? Are we good with your geometric mean? Okay.
Yes, sir.
Now, the Lawrence wants to earn a minimum annual return of 5%. So they want a minimum annual return of 5%. The annual return and investment amount are presented in Exhibit 13. Okay. Is the money weighted annual return greater than 5%? the money-weighted annual return. So it's asking us now, what is the money-weighted annual return? So you can see from Exhibit 13 that has broken this down, right? That has broken it down. How can you use this figure to calculate? How can you use this table to calculate money-weighted return? I want someone to talk to, before we go to the answer, given this table, how are you going to approach setting up for a money-weighted return calculation? Anyone?
Okay. Year 0 will be CF0. The cash flow for 0 will be 34.50 minus 34.50. Since they are using 5%, it will be 1 plus 5% raised to power 0.
Hold on. I'm asking you, remember how you set up your money-weighted return calculation? You know that
I
the
think
first
it will
step
be
really
30 for year
is to
0.
derive your cash flow. How do you derive cash flow from this table? I guess that's my question.
Okay.
Yeah, so that the 30 will be for year 0 minus 30 now.
No, so so CF0 is 30. Continue.
Yeah. CF1 will be 34.5.
CF1 will be 34.5. Okay.
Then CF2
CF2
will be
42.75.
42.75.
No, sorry. I
Yes.
don't agree.
You don't agree?
No.
Good. Yes.
Just hold on.
The reason why I don't agree is because it's a rolling balance.
Yes.
So it should just be the movement that we should be looking at.
It's just the movement, right? And so on this table, which are the movements?
30, 10, minus 20.5, 36.25.
Exactly. So guys.
Yeah, exactly.
So that is why it is important to break it down this way. So you can see that all that was given really, this Exhibit 13 is really just to give you expo. In an exam, you might be given only Exhibit 12, and then you are asked to calculate money-weighted return. So how do you calculate how do you calculate your cash flow from here? So you then have to break it down. But the breakdown and the logic to go through the breakdown is what we've done in Exhibit 13. And once you've done the breakdown, which one represent cash flows? Cash flows are the monies that, take Rand Value Superior as an investor. So the money you put in is your outflow. The first one would be your 30. Every other cash flow you count from there will be inflow and outflow. Money that comes to you or money that didn't come to you. Any money that's still in the fund is there until the maturity of the period. So that really doesn't really count until the maturity of or to the end of the period. So what you are then looking out for is there any additional money which your additional investment would highlight? Is there withdrawal, which your withdrawal will highlight? So you see, you are right when you say that what you will consider will be the initial value, the 30, and then you will consider all of the additional money that was put in, which is the new investment, which is the 10.53 and the 6.5. And then you will also consider any money that was taken out, which is the 22.75. And then you will consider the last balance, which is the 36.05, because that is now the value, the ending value of that investment. And so that is how you derive your cash flow from here for use. So now let's go back to the question and then see the methodology. So you can see here now that for CF1, it is minus 30. For CF0. For CF1, it's only the 10.5, which is only the withdrawal value. sorry, only the new investment value, 10.5. For CF2, is the 22.75 withdrawal. And for CF3 is the -3. For CF4 is the -6, that is the new investment. And then the CF5 will be the balance in the portfolio, which is the 36.05, which is the 36.05. Now, that way you now have your CF0 to CF5. And then you can then plug that into your IRR calculation. Is it clear a bit?
Sorry, I didn't get your last statement. The 36.05, CF5.
Yes, CF5.
Why is 36.05?
The reason for that is it is always assumed that you terminate the investment at the end of the period. So whatever period you're given,
I'm withdrawing the total balance.
Exactly. Okay. And the total balance as at that time will be 36.05. Notice it is not 35. It is 36.05. That will be the balance in the portfolio at the end of the year. So, and it is assumed that you terminate it, which means, well, if you terminate it, that money comes to you. So it's an inflow. So that will be your end of year, end of period, or end of investment inflow to you.
Okay, so can I ask a question?
Please ask.
Yeah, so the impact of the gains, why don't we take them on an annual basis? Or has it been reflected in the cash flow, the 10.5 and the likes?
It is reflected implicitly, and that's why it's called the internal rate of return. So when you take out the effect of the cash withdrawals and the inflow, the impact that is left really is the impact of the return. And so even though you see that return, even though that you see return is 15 minus 5, 10, 15, or 3, when you look at the actual investment, which part of it can you attribute really to return? Can you attribute really to return? And that is the IRR. The rest would either be magnified or dampened by withdrawal or additional investment. Do you get? So really, it distorts the actual return. But when you break it down this way, what is left is the actual impact of return, and that is what the IRR measures really, to say that, okay, taking into consideration the withdrawal and everything or the additional money, what return really did this investment generate on an annual basis? And that's what the IRR measures. To say that if we net off everything, all the money that comes in and all the money that goes out, really what rate of return has we really returned, has this investment generated? And that is what the IRR represents. So that is why you don't use the annual rate of return in your calculation, because it's already reflected. It will be reflected in the IRR. That is actually what you're looking for. That is why you're calculating the IRR, because the annual return you're giving here will be distorted or will be affected by so many other factors, like the withdrawals and the additional investment. Is that clear?
Yeah, that's fine.
Good. Now, once you have identified your cash flows, which is this, you can then plug that into your formula and then calculate what your IRR is. In this case, because you're already given an IRR to work with, so the question is the money-weighted annual return greater than 5%? How do you know? Simply put the 5%, simply take the 5% as the IRR and plug it into your calculation. Now, when that is plugged into the calculation, you find out that you have an NPV of 1.1471. This is an NPV, 1.171. This is supposed to be 0, but it is 1.171, right? And which means it is positive. Now, if it is positive, and you need to take it and you need to make it 0, which means you need to make this 0. You need to bring this down to 0. What you do to your IRR is that you take your IRR up. Now, when you take your IRR up, yes, your NPV will come down. So, because the NPV is very small, plus 1.17 is very small, it means maybe what you need is simply a very small adjustment to your IRR. You already have your IRR at 5%, but it's giving you a positive NPV, but you want it to give you a 0. So what that means is that you will have to adjust it up a little bit, which means the actual IRR will be higher than 5. The question really wants to know if it is higher than 5. Look at the question. The question is not really asking you to calculate an actual IRR. It just wants to know if it's higher than 5. And when you plug in 5 into the calculation, you got a positive NPV, which means for you to bring it to 0, you will need to increase the IRR, which means the actual IRR will be higher than 5. That answers your question. The IRR is higher than 5. That's what it means. Do you understand? Let me take it again. Question 4, right? The Lormans wants to earn a minimum IRR of 5%. That's the minimum, right? If it's higher than that, they are fine, but it cannot be lower than 5. So they want to know, does this investment generate an IRR that is more than 5%? That's the question. Is the money weighted annual return greater than 5%? That's the question you want to answer, right? In your exam hall, they will not give you returns. The answer will either be yes, no, we cannot see, or something. So you have to select either yes, no, or you cannot see, right? Now, how do you then find that out? Based on the data you've been given, you calculate your IRR. But because IRR uses interpolation, all you need to do, a moment, please.
Yeah, with you.
Okay. So the question really is, is the NPV, is the money weighted annual rate of return more than 5%? So what in that case, what you just need to do is substitute, assume that your annual rate of return is 5, the money weighted return rather, and put it into your calculation. You already have your cash flows. Put it into your calculation and get an NPV. Now the NPV derived from this is 1.1, which is a positive NPV. Because it's a positive NPV, the actual IRR that will make that NPV negative or 0 will have to be higher than 5. Because if you need to adjust this down, it means you need to increase the money weighted annual return. You will need to adjust it up. It can only be adjusted up. But the implication of that is, since the actual money weighted return, IRR, has to be something that gives you 0, it means you have to adjust this up, which means the actual IRR is higher than 5. So to answer your question, yes, the actual IRR is higher than 5. That is, this investment generates an IRR that is greater than 5. That is the question you want to answer. So look at the logic. You plug in the 5%, right? You got a positive NPV. For you to get a 0 NPV, you will need to increase your IRR. Because once you take your IRR up, maybe to 5.5, then your NPV will become 0. Therefore, the actual IRR will have to be higher than 5. It cannot be 5 because you still have a positive NPV. If you calculate this and you get a negative NPV, the implication is that you have to reduce the IRR. In this case, you used 5, which means you have to bring it to maybe 4.8 or 4.5 for you to get 0. That way, you will say that the money weighted annual return is lower than 5. But in this case, it is higher because you got a positive IRR. Sorry, you got a positive NPV. Is it clear?
Yes, sir.
All right. So, I think we will end here today, looking at money-weighted return. The next class we will look at time-weighted return. I'll take any question before we call it a class today. Is there any question? Any question? Okay.